Night gathers at the edges of a room that could belong to anyone, a square of stillness where air slows, where a pulse in the throat finds a softer rhythm. The last lamplight fades into a quiet sheen on the ceiling. Curtains move by a fraction, a small tide pushed by a window's imperfect seal. A sleeper turns and exhales, and in that exhale lies a gate. Not a door of wood and hinge, but a threshold made of attention loosening, of thoughts surrendering their sharp outlines, of the world drifting just far enough away that a second world may be felt beneath it. The camera of the mind tilts, and the ordinary gains a faint translucence. Inside that translucence sits a rumor that modern physics will not let go. Reality may not be one road, it may be a braided river, with currents that separate and never meet again, each rippling with different stones underfoot. A single breath, a blink, a sigh, these small events arrive inside a universe that might be plural. A clock ticks in the hallway. Each tick divides a future from a future. The sound is simple, yet it feels like a metronome for possibility. In the darkness, the mind rehearses a day that has not happened, then forgets, then builds another. Memory and imagination mingle, and diffusion begins in the sealed chemistry of the skull. Neurons speak with waves of electricity. Sodium slips across a membrane. A cascade lights the cortex like a distant city seen from an airplane window, a lattice of moving points. At this scale, the rules feel calm and unbreakable. At a smaller scale, near the unseen basement of things, a different etiquette prevails. Particles take on the roles of travelers and shadows at once. A single object occupies several states, as if the world has learned to hum more than one note at a time. The hum does not sound in air. It is a mathematical vibration called a wave function, a grammar of maybes written in complex numbers. To sleep is to lie down beside these maybes and let them speak through metaphor. A child once asked why a star can be in two places. The answer began with hands and coins and benches, as all answers to impossible questions often do. But the true answer lives in a strange courtyard. Imagine a coin tossed into the night. It is not heads or tails until someone looks, the explanation goes. That picture stands in for a deeper fact. The coin and the air and the fingers and the eye become entangled. The world ties itself to itself, and the knots decide what becomes actual. Entanglement is not romance, it is bookkeeping, a perfect accounting where information is conserved while certainty emerges. Before that emergence, the coin's possibilities coexist. The coexistence is not a mist, it is a structure with teeth, able to interfere with itself, the way two ripples in a pond cross and leave a pattern of dark and bright. In laboratory light, this interference writes bright fringes on a screen. In life, it writes an intuition that something hidden supports the visible. A planet turns under this bed, under all beds. The turning drags dawn toward the window. But in this hour before first light, the boundaries of the self soften. The senses switch to a night mode. Taste and smell become distant. Hearing keeps watch. The mind enters the theatre of sleep, where fragments of memory become scenery for messages that no one quite authored. Sleep appears simple, yet across the cortex, the choreography is intricate. Waves slow and rise, then sprint and scatter, channels open, systems that store the day's traces, replay, and rebind them, pruning some paths and widening others. The sleeper is unaware of any of it. The sleeper is ashore while storms far offshore shape tomorrow's coastline. In the story that science tells, the brain is making futures. In the story that physics tells, the universe may be doing the same, not in one draft, but in many. Consider a hallway lined with mirrors. The mirrors do not copy the viewer, they multiply vantage. Take a single step, and 100 versions of the step appear to march away. In the quantum story, a single microscopic event does something similar in a more austere language. The event becomes part of a grand wave of possible outcomes. When conditions cause that wave to spread into parts that no longer interfere, the parts evolve as if they were separate worlds, not by choice, but by mathematics. The technical term is decoherence. It sounds like a fall from harmony, but it is a bookkeeping transfer, a shift from delicate superpositions into robust records. The records are what large beings inhabit. A sleeper is a record keeper without knowing it. Every heartbeat is a mark, every breath a stamp. The marks feel singular, Floating between waking and dreaming, the sense of singularity loosens. What if singularity is a convenience rather than a law? The bed carries a body. The body carries a brain. The brain carries trillions of interactions. The scale is human. The clock is ordinary, yet the microphysics below has not turned off. It remains as the foundation that built the bricks. That foundation invites a scandalous idea. If a wave of maybes never truly disappears, if it only spreads and ceases to interfere across vast environments, then potential outcomes continue as separate strands that no observer can rebraid. There is no shattering pop, no cosmic finger snapping decisions into being, only a branching of descriptions that grows denser with time. Branching is a metaphor, but it points toward a cold clarity. The world could be spacious enough to hold every lawful variation implied by its initial conditions. In that spaciousness, sleep becomes more than restoration. Sleep becomes a soft rehearsal for plurality, a nightly apprenticeship for coexistence with unseen neighbors that are not ghosts, but logical continuations. Moonlight moves across the floor. A moth finds the window and taps, then rests. Somewhere in the city beyond, a signal changes from red to green. Somewhere else, a coin lands on a sidewalk. These events unfold in the usual way that minds agree upon. Agreement builds a society of moments, a network of shared history with the consistency of stone. Yet the stone may sit atop strata of shale that part along hidden plains. At the quantum plane, a measurement is an interaction. An interaction is a weaving. The weave defines what counts as a definite fact. Facts then compose the furniture of experience. The furniture feels singular because it is, in this branch, in this record, in this story. Poetry steps in here, not to mystify, but to widen the feeling of what might count as real. If the law is abundance rather than selection, then the mind at rest can entertain a grace note. The grace note says, there is room for every version that physics allows, even if only one is lived and remembered here. In the stillness of the room, time wears a different face. Minutes do not march, they pool. In the pool, images rise. A path through a forest appears, then shifts into a coastline, then a staircase cut into iron. The sleeper descends. Footsteps make no sound. The descent becomes a drift, not down, but sideways into a texture that is not place at all. The texture is a catalogue of alternatives, silent and vast, like snow falling in a sealed cathedral. No choice is made inside this drift. Choices already sit in their frames, lit by the logic that allowed them. The astonishment is not that they exist, but that awareness lands in only one. Perhaps astonishment is the correct attitude for a species that learned to speak in the language of monologue in a universe that may be a chorus. A car passes, and the headlights slide across the wall. Shadows lengthen, then vanish. The sleeper does not stir. The geometry of the room remains. Gravity holds. The laws do not blink. Within those laws sits indifference and generosity at once. Indifference, because the laws do not choose favorites. Generosity, because they allow a plenitude of outcomes without contradiction. The most unbelievable fact presents itself calmly. Reality may be larger than any catalogue the mind can carry, yet it may also be close as a breath released in darkness. Sleep becomes a gentle rehearsal for trust in what cannot be tallied. The body lies in one bed, but the law that shapes its atoms may lay out 1,000 beds in parallel, each with a life unfolding. Not a promise, not a threat, but a possibility presented without fanfare by equations that have endured every test given to them. Dawn waits just off stage. The first bird holds a note at the far edge of hearing. In this pause before light, the heart and the cosmos share a tempo. The cosmos does not hurry. The heart learns not to hurry either. A room, a breath, a mind loosening, a law that leans toward abundance. These are the elements. If the future is a map with many roads inked already, then wonder is the compass that makes any road bearable. The sleeper drifts deeper. The world holds its shape. Possibility gathers, not as chaos, but as a patient library built one lawful shelf at a time. The shelves extend beyond sight. Silence approves. The unbelievable becomes a gentle companion. Nothing need break. Nothing need be forced. There is space for every branch to exist, and there is tenderness in choosing to hold only one at a time. The room grows quieter. Night gives its last gift, a feeling of proximity to things that cannot be seen. The sleeper takes it, although the sleeper will not remember taking it. The gift remains. It is tucked under the pillow of the world. In 1957, a young physicist named Hugh Everett III sat alone in a small Princeton office, surrounded by papers, chalk dust, and a kind of silence that often visits those who dare to question reality itself. His notebooks were filled with equations describing how the universe might not be singular, but a web of overlapping possibilities. He was 26, polite in conversation, but relentless in thought. Everett's idea was not born from mysticism or science fiction. It grew from a simple dissatisfaction with how the world of the very small seemed to behave differently when someone looked at it. Quantum mechanics worked perfectly as mathematics, yet its interpretation demanded something deeply uncomfortable. Observation appeared to dictate existence. To Everett, this seemed too arbitrary, too human-centered. He asked a heretical question: what if observation does not collapse the wave function at all? What if every outcome continues, not as an illusion, but as a legitimate universe, following its own consistent rules? That thought, written in dense symbols, quietly changed the landscape of science. He called it the relative state formulation. Later, it would be renamed the many worlds interpretation, a title that would echo through decades of argument and wonder. Everett suggested that when an event can lead to multiple results, all of them occur, but in distinct branches of reality that no longer interfere with one another. The observer does not force a choice. The observer simply becomes entangled with one version of it. In the sterile corridors of the Institute for Advanced Study, where Albert Einstein had once walked, Everett's idea was met with unease. The mainstream view, led by figures like Niels Bohr, insisted that quantum events only became real when measured. To them, Everett's theory seemed reckless, an unnecessary multiplication of worlds. Yet to Everett, it was the only way to preserve the mathematics without invoking a mystical line between the observer and the observed. The universe, he thought, could be clean and deterministic beneath its apparent randomness, unfolding like a grand equation that never erases its steps. Outside those quiet offices, the mid-20th century was a time of expansion. Humanity was reaching into orbit, mapping the atom, and beginning to understand the deep structure of time and energy. The idea that every quantum decision might generate a parallel cosmos fit oddly within that era of optimism. It suggested infinity not as metaphor, but as architecture. To believe in it was to accept that the entire cosmos might be rewriting itself endlessly, producing variations where each possibility of each particle lives out its consequence. Everett's notes spoke of branching, but he avoided poetic language. He remained mathematical, precise, almost cold. Yet the implications were profoundly intimate. If his equations were correct, each human gesture, each breath, might resonate through countless parallel versions, all existing, none aware of the others. Everett presented his doctoral thesis and received his degree, but his idea was too far from comfort to take root. He left academic life soon after, working on mathematical models for defense projects, his great hypothesis quietly aging in obscurity. Yet science, like gravity, is patient. Years later, the thought he had written in chalk began to stir again in the minds of others who found the same mathematical tension he had tried to resolve. The mathematics of quantum theory had no place for collapse. It described evolution that was smooth, unitary, never skipping or erasing. The collapse was an extra ingredient, added only because it felt necessary to fit experience. Everett's insight was that maybe it was not necessary at all. The equations could describe the total reality, if one accepted that reality was far larger than perception. Decades passed before the world took him seriously. Physicists like Bryce DeWitt re-examined the work and began to see that Everett had not been proposing fantasy. He had been describing a universe that obeyed its laws completely, with no exceptions. Every quantum event would split the total state of the universe into distinct, non-interacting outcomes. It was not that the universe made choices, it was that it expressed all of them simultaneously. This was not an easy thing for the human mind to hold. The human experience depends on exclusion, on the feeling that only one version of a story can be true. But Everett's mathematics implied otherwise. If his theory was right, then the boundary between possibility and reality was an illusion drawn by limited perspective. Each measurement, each entanglement, became a branching of world lines. The branching did not require energy or time to perform. It was embedded in the structure of the wave function itself. To those who listened closely, the mathematics was almost serene in its certainty. What felt chaotic and unpredictable was, in Everett's picture, a complete and deterministic unfolding. The randomness perceived by observers was simply the reflection of their limited access to the total picture. He once said that he found comfort in this view, that it removed mystery from physics. Yet to others, it added more than it resolved. If every version of a person exists somewhere, what becomes of identity? If every outcome unfolds, what becomes of consequence? These were not questions Everett tried to answer. He left them for philosophers and poets, content that his equations worked. But they have haunted science ever since. In the years after his death, the notion of many worlds began to spread beyond physics. It seeped into literature, philosophy, and even the way people dreamed of themselves. The world that Everett described was not one of fantasy, but of logical necessity. Each quantum process, however small, was a branching. The totality of all branches was the universal wave function, a timeless whole. Inside it, nothing was ever truly lost, merely partitioned beyond reach. There is a quiet irony in the life of the man who conceived infinite universes yet lived within one of such constraint. His discovery grew like a hidden seed, nourished by generations who could not let go of its strange simplicity. It began as a student's dissatisfaction, became a forgotten thesis, and now forms one of the most provocative interpretations of reality ever written. The young physicist who once sat alone among his papers unknowingly gave language to the idea that the universe itself might be dreaming all possible versions of itself at once. In the ordinary rhythm of life, cause and effect appear faithful. A glass slips from a hand and shatters. The sound is sharp, the pieces are finite, and the moment seems irreversible. But quantum theory hides a subtext beneath this simple order. Beneath the visible sequence, probability hums like a hidden current. When Everett's idea of branching worlds entered the stage, it carried a subtle, devastating implication. Probability might not be a measure of chance at all. It might be a census of existing realities. Every event that seems uncertain could be a gateway to a full, autonomous universe. This notion struck science with a mixture of wonder and unease. The shock was not that the mathematics permitted it, but that it required it to remain honest. If the equations of quantum mechanics describe the evolution of a wave of all possibilities, and that wave never collapses, then those possibilities never truly vanish. They separate. Each possible outcome becomes real within its own frame, distinct and untouchable to the others. The simplicity of the logic was unnerving. What appeared as randomness might be the shadow of a grand determinism too wide to observe in total. In this picture, probability ceases to be a measure of ignorance. When one rolls a die, it does not merely land on a number. It lands one every number, each result realized in its own continuum. The observer experiences only one because consciousness travels along one thread of that branching tapestry. The rest unfolds simultaneously, unnoticed, complete, lawful. The meaning of chance dissolves. Nothing is truly random. It only seems so because the observer perceives one narrow slice of a vast geometric structure. For centuries, science had relied on the comfort of singularity. One experiment, one outcome, one world. Now the notion that every micro-choice births entire universes pulled that comfort away. Even Schrödinger's famous cat, once imagined as a thought experiment about ambiguity, found itself reborn in this framework as a literal multiverse resident, alive in one world, dead in another, both equally real. To physicists who had built careers on precise prediction, the idea that nature's book contains all drafts at once felt both elegant and absurd. The deeper implication was psychological. If every decision spawns new realities, then existence becomes an infinite branching tree of selves. There is a version of each person who turned left instead of right, spoke instead of staying silent, lived instead of perishing. The awareness that now reads these words is only one branch among innumerable siblings, each following its own coherent line of events. To some, this was liberation. To others, it was vertigo. The comfort of singular identity began to blur. The universe was no longer a stage with a single performance, but a theatre of endless improvisations, all playing at once. The philosophical tremor spread beyond physics. Determinism, free will, destiny, words that once carried certainty, had to be reconsidered. If all possibilities occur, the idea of fate loses its tyranny, but the idea of choice loses its drama. The self remains important only within its branch, like a melody that makes sense inside one movement of an infinite symphony. The harmony across all movements exists, but no ear can hear it whole. This view also reshaped how scientists thought about prediction. In a many worlds framework, probability describes not the odds of an even happening, but the fraction of branches where it is observed. The Born rule, that strange law connecting amplitude with likelihood, becomes not a trick of statistics, but a description of measure across universes. It defines which outcomes dominate the landscape and which remain delicate and rare. In this way, physics quietly absorbs metaphysics. What once was mystery becomes measure, yet the shock of this realization was more emotional than mathematical. To live in a single world is to believe that outcomes are precious because they are unique. To live in a multiverse is to confront abundance so vast that uniqueness dissolves. Each joy, each loss, each heartbeat becomes one of countless repetitions, eternally varied. The mind resists such plenitude. It prefers the intimacy of one life, one chance. But physics is indifferent to preference. Its laws describe what must be, not what comforts. Some scientists looked for a refuge in probability's old meaning. They hoped that perhaps the branching was metaphorical, that the other outcomes were mathematical ghosts, not physical realities. But the mathematics offered no such kindness. Each branch carried its own consistent history, its own light, its own observers who would swear they alone were real. In that mirror hall of existence, every version of a world believes itself singular. The grand design conceals its multiplicity within perfect self-consistency. To imagine this is to feel both small and infinite. A coin toss ceases to be trivial. It becomes a cosmic event, splitting the totality of reality into parallel rivers. A conversation, a glance, a delay of 1 second all create new paths. The universe, under this lens, is not static but continuously blooming, every atom writing its own multiversal diary. The energy of creation never ceases, it merely divides into quieter echoes beyond reach. For scientists, the question became not whether this was possible, but whether it could ever be tested. Yet even before tests could be conceived, the conceptual shock had already rewritten the intellectual landscape. The nature of existence had shifted from being a singular line to being a forest without boundary. The equations that predicted a particle's behavior in a lab were the same ones predicting the birth of entire unseen worlds. As the world continued its ordinary motion, as suns burned and cooled and civilizations built telescopes to study distant light, the deeper implication remained. The structure of reality may not be a single universe, but a continuous field of outcomes, each complete and entire. The simple word probability, long treated as a measure of ignorance, becomes a map of infinity. In this quiet revolution, physics revealed its most disquieting truth. What we call chance is merely the local reflection of universality. Every outcome exists somewhere. Every possibility is realized. The coin that falls, the photon that passes, the heartbeat that skips, all belong to the same endless ledger, written in a language of amplitude and phase. Nothing is lost. Everything persists. The world that each observer inhabits is a single leaf on a tree whose roots run through eternity. And as that tree grows without end, it erases the illusion of randomness and replaces it with an architecture of inevitability. Probability becomes reality. The dice were never cast, they were multiplied. In a quiet laboratory, 2 narrow slits are carved into a thin metal plate. Beyond them stands a dark screen ready to record whatever light might pass through. The setup is simple enough for a student to assemble, yet it contains the entire riddle of quantum reality. When a single photon travels toward the slits, one might expect it to pass through one or the other, leaving two bright marks on the screen. But that is not what happens. The screen shows a series of alternating bright and dark bands, a pattern of interference. It is as if the photon has interfered with itself, as though it had traveled through both slits simultaneously and then met itself again on the other side. This experiment, so small and so pure, forces the mind to consider what kind of world allows such behavior. If the photon is a particle, its path should be definite. If it is a wave, it can spread and overlap. But when the photon is observed, when one asks which slit it went through, the interference vanishes. The photon behaves as if it made a clear choice. The very act of observation changes the outcome. The laboratory becomes a stage where mystery performs in the plain light of reason. To physicists, this is not a trick. It is the most faithful demonstration of quantum law. The world does not wait for observers to decide. It follows equations that allow potentialities to coexist until conditions force them apart. For a time, this paradox was explained through convenience. The wave function was said to collapse upon observation, resolving into one reality. Yet deeper study revealed that the interference pattern could reappear if the environment was carefully controlled, even when no human eye watched. The crucial factor was not awareness, but interaction. Whenever a quantum system becomes entangled with its surroundings, air molecules, photons, measuring devices' information about its state leaks away, and the delicate superposition dissolves. The process is called decoherence. It explains how the world transitions from the ghostly quantum haze to the firm outlines we experience. Decoherence is not destruction, it is separation. The interference between possible states fades because each state becomes woven into a different environment. The world branches not by will, but by inevitability. Each branch holds a version of events where outcomes are distinct and non-communicating. What looks like collapse is simply the loss of coherence between them. The slits experiment, so often used as an illustration of mystery, is also the quiet revelation that every particle carries a universe of possibilities that unfold in mathematical precision. The more precisely experiments are performed, the clearer this structure becomes. Electrons, neutrons, even entire molecules have shown interference patterns, confirming that quantum superposition extends far beyond light. In ultracold chambers, physicists have observed matter waves interfering across macroscopic distances. A molecule hundreds of atoms wide can behave like a single wave that passes through two paths at once. It is not that reality behaves strangely, it is that human expectation has been too narrow. The laws that govern the small do not stop at size. They whisper that everything large is built from countless overlapping probabilities, decohered into solidity only by interaction with an immense environment. At its core, the double-slit experiment does not only reveal the duality of particle and wave, it unveils the continuity between knowledge and existence. Information about a system defines what can be said about its reality. If no information distinguishes the possible paths, interference persists, and all possibilities coexist. Once information is recorded even invisibly, in stray photons scattered to the room, the coexistence ends. The observer does not create reality. The observer becomes part of it, embedded in one of its many outcomes. Each attempt to refine the experiment deepens the astonishment. Detectors are added, then removed, then delayed in time to see if the past can be changed by future observation. Quantum eraser experiments show that the interference pattern can vanish or reappear, depending on whether information about the particle's path is preserved or erased. The implication is subtle but profound. Reality's structure depends on the flow of information, not on the presence of consciousness. The boundaries of the world are drawn by correlations, not by awareness. In laboratories cooled near absolute zero, physicists now trap photons and atoms long enough to watch decoherence in real time. They see the gradual loss of interference as systems become entangled with their surroundings, the transition from the fragile quantum realm to the solid classical world. It happens quietly, without drama, a smooth fading of mathematical overlap into definite existence. What once looked like mystery now appears as a process of separation, each version of the system branching into its own history. The universe may behave like a grand interference pattern, its vast structure built from waves that add and cancel across invisible dimensions. The dark spaces between bright fringes are not emptiness, but regions where possibilities subtract. The bright bands are where paths reinforce. This dance between coherence and decoherence gives birth to everything visible. Galaxies, stars, and human lives may all be the stable fringes in an interference pattern written by the wave function of the cosmos. Every new refinement of the double-slit experiment continues to whisper the same lesson. The world is not built from solid pieces. It is built from relationships, from information exchanged and preserved. When those relationships remain delicate, reality behaves like a wave of potential. When they harden, the world takes form. In this framework, mystery and measurement are not enemies. They are partners performing an ancient rhythm. Somewhere, light still passes through those slits in a quiet room. It travels alone, yet divided, tracing paths that multiply without witness. On the screen, a pattern appears, a pattern that repeats the same truth with every photon that lands. The universe is not choosing between alternatives. It is showing all of them, each in its proper place. To look closely is to see the boundary between existence and possibility blur until they become indistinguishable. Word count. 1154 est supérieur à est supérieur à est supérieur à awaiting un. Bạn đã nói. Woo. Thiên văn 15 section đã nói. Section 5. A pale afterglow fills the universe like the memory of a fire that burned long ago. Astronomers call it the cosmic microwave background, a bath of ancient light arriving from every direction with a near-perfect uniformity. Its temperature hovers just above absolute zero, yet in that chill there are ripples no thicker than 1 part in 100,000. Those ripples function as fossils, tiny imprints left by processes that unfolded when the cosmos was young. To read them is to read the first sentences written by space itself. In those sentences, hints gather that reality may be larger than any sphere telescopes can see. The theory that gives this afterglow its stage begins with a brief and violent swelling. Inflation proposes that in a fraction of a second, the universe expanded with such speed that regions once close were thrust far beyond reach. The expansion smoothed wrinkles, flattened curvature, and diluted relics that would otherwise have cluttered the sky. A small quantum tremor could be stretched to colossal size, seeding the later pattern of galaxies. This picture solves old puzzles with a single act. It explains why distant parts of the sky share the same temperature despite never exchanging light since the first moments. It explains why geometry appears flat rather than curved like a closed sphere or a saddle. The precision of satellite maps supports these claims with quiet insistence, reporting small deviations from perfect scale invariance that match the expected fingerprint of an inflating field. The sky becomes a ledger where early physics signed its name. If inflation is correct, its logic rarely ends with a single universe. Fields that drive rapid expansion behave like landscapes with ridges and valleys. In many versions of the theory, the expansion never completely stops. Some regions finish and cool, forming pockets where stars and planets can eventually arise. Other regions continue to swell, giving birth to more pockets that can themselves spawn still more. This process is called eternal inflation. It fills the totality with a mosaic of bubble universes, each one locally finite and aging, all of them embedded in a background that keeps growing. The observable sky would then be a small window on a far larger quilt. Astronomers do not see those other pockets directly. What they can see are anomalies that sit like quiet questions in the microwave background. One patch of sky appears slightly colder and larger than chance would suggest. Some alignments of temperature fluctuations hint at a preferred axis where none should exist. These features may be statistical accidents, they may be artifacts of foreground dust or imperfect modeling, or they may be the first whispers of a wider structure beyond the horizon. A collision between two cosmic bubbles in the early epoch could leave a circular scar, a faint ring of temperature modulation, or a gentle gradient frozen into the afterglow. The search for such signatures is a study in patience. It demands clean data, careful subtraction of galactic emission, and a firm grasp of how randomness dresses itself in patterns. The expansion that smoothed the infant universe did not erase quantum behavior. Fluctuations in the inflating field jittered with subatomic restlessness, then were stretched to cosmic scales. When expansion slowed, and the energy driving it decayed into particles and radiation, those stretched fluctuations remained as density differences. Gravity later amplified them, pulling matter into clumps that would become galaxies and clusters. The statistical properties of these primordial ripples carry the accent of their origin, slight departures from a perfect power law, the tendency for fluctuations to be almost but not exactly scale-free, and the near Gaussian distribution of temperature variations all point toward an inflating past. The details read like fingerprints pressed into cooling clay. Flatness offers another sign. In a universe that did not inflate, any initial curvature would grow robust over time. Observations instead reveal a geometry indistinguishable from Euclidean space on the largest scales. This does not prove inflation, but it sits comfortably within its expectations. A rapid early swelling iron's curvature thin until it becomes nearly impossible to detect. The sky is not a perfect proof, yet it is a consistent witness. If reality hosts a multitude of pocket universes, each pocket could exhibit different low-energy properties depending on how fields settle as expansion ends. Some may be poor hosts for structure. Some may never form stable matter. Others might produce stars but no heavy elements. A few might resemble the one seen from Earth. Inflation does not require such variation, yet many versions allow it. The result is a cosmic archipelago where each island has its own weather and geology. From within one island, the sea is invisible, but the breakers still shape the sand. The search for direct traces of neighboring pockets turns to polarization maps of the ancient light. A collision could tilt the pattern of polarization across a patch of sky or imprint a faint asymmetry in the statistical distribution of fluctuations. Researchers build instruments in deserts and on high plateaus where the air is clean and still, chasing the delicate swirl patterns that would betray gravitational waves from the first moments. These waves could be fossils of inflation itself, a roaring chorus of space-time vibrations damped by expansion and now barely audible. Their detection would not confirm other pockets, but it would anchor the mechanism that so easily generates them. A single success would change the conversation from speculation to engineering new tests. The horizon defines the limit of what light can show. Beyond it lies more of the same, if the simplest models hold. Yet the same can include surprises. A slight negative curvature could hint at curvature produced by collisions. A statistically rare cold region might quietly signal an ancient encounter. Temperature and polarization cross-correlations could reveal inconsistencies with simple pictures. Each of these hints faces an obstacle. Cosmic variance limits how well one can measure the largest scales because there is only one sky. Foregrounds produce confusing signals. Instrumental noise can mimic fragile patterns. The discipline required is relentless. Models must be tested against simulations that include every known source of contamination. Claims must survive multiple independent analyses. The sky offers few certainties and many temptations. There is another, subtler clue. If eternal inflation is correct, the global picture is dominated by regions that keep expanding, while habitable pockets remain small in the whole. Observers must then find themselves in those pockets by selection. The statistics of what kinds of pockets allow observers may influence what constants and initial conditions are likely to be measured. This line of thinking does not deliver a crisp prediction, but it shapes expectations about what the sky should not show. If the values measured were wildly rare among observer-friendly pockets, the framework would be strained. Instead, the numbers sit within ranges that, while remarkable, do not shatter plausibility. The sky yields a quiet compatibility. Instruments continue to refine the map. New satellites and ground arrays improve angular resolution and sensitivity, separate foregrounds with better frequency coverage, and tighten constraints on departures from Gaussianity. Each improvement narrows the space where exotic alternatives can hide. If the anomalies fade with better data, they will have taught a lesson about the craft of measurement. If they persist, They will become lanterns hung at the edge of understanding, drawing new theories toward them. The afterglow remains, ringing the universe with light that has cooled for billions of years. It is a veil and a window at once. Through it, one sees a universe that likely passed through an era of breathtaking expansion, an era that naturally breeds other realms beyond sight. Whether those realms leave signatures that instruments can secure is an open question, but the hints in the sky keep pointing outward. The simple dome above the planet becomes a shell, encasing an ocean without shore. The map is incomplete. The horizon is not a wall. It is a suggestion that there is more. Several roads point toward a larger reality, and each road carries a different accent. One pathway speaks in the language of branching, where quantum states remain intact and decoherence divides outcomes into quiet, non-communicating lines of history. Another pathway imagines space swollen by a restless field, where regions finish their expansion and cool, while others keep racing outward, leaving a mosaic of cosmic pockets. A third pathway stretches across a mathematical landscape of possible vacuum states, where the same fundamental equations allow many low-energy worlds with different constants. A fourth pathway proposes that everything inside a volume is encoded on a distant surface, that gravity and space may arise from information painted on a boundary. Together, they do not agree in all details, yet they rhyme. Each tells a version of abundance, each opens a gate where singular reality once stood. In the first, the story is intimate. The entire universe is a wave that never collapses, a vast book whose pages are written in amplitudes and phases. When interactions spread information outward, the pages separate into narratives that no longer interfere. The mathematics remains unitary, precise, and unforgiving. There is no need for special rules that single out measurement, no stage direction that commands reality to choose. The cost is conceptual. Identity becomes local to a branch. Memory becomes a record within one history among many, and probability becomes a measure over structure rather than a roll of dice. This world is plentiful even while it feels solitary to its inhabitants, who experience one line of events with perfect conviction. In the second, the stage is cosmological. A field with high energy density drives a rapid swelling of space. Quantum jitters of that field seed structure and, in many models, keep some regions inflating forever. Where inflation ends, a bubble forms, cools, and evolves into a universe with matter, stars, planets, and questions. Elsewhere, inflation continues, and from that inflating sea new bubbles bud. None of these bubbles can exchange ordinary signals once they are well separated, yet a grander whole contains them. This picture replaces a singular cosmos with an archipelago scattered across an ocean of expansion. It retains classical space and time region by region, while assigning the plenitude to a geography that no observer can survey entirely. In the third, the grammar grows abstract. The fundamental theory permits many solutions with different shapes for extra dimensions, different patterns of symmetry breaking, different values for the constants that shape chemistry and life. Each solution defines a vacuum, a low-energy resting place for the fields that build matter and force. If a cosmological mechanism samples many vacua, the result is an immense roster of possible worlds. Selection can then occur not as a mystical choice, but as a demographic fact. Observers will arise only in those pockets where the constants allow complexity to survive. This does not predict unique values. It predicts ranges consistent with the existence of structure and attention. It trades sharp answers for a framework where likelihood is measured by the population of habitable niches across a mathematical continent. In the fourth, the picture inverts. A region of space with gravity is dual to a theory without gravity that lives on its boundary. The boundary stores the information that lists everything the bulk can do. Spacetime becomes a hologram, an emergent fabric woven from correlations in a non-gravitational system. Black holes fit smoothly into this scheme, their entropy counted by the area of a horizon and explained by boundary degrees of freedom. The bulk interior becomes less mysterious when seen as a shadow cast by more fundamental data on the edge. This route does not multiply visible universes in the everyday sense, yet it multiplies descriptions. One physical situation can be translated into another, with different variables, and the full content of a gravitational world can be represented elsewhere, as if reality were fluent in two languages at once. These roads intersect at strange crossroads. Branching thrives in the microphysics of measurement and computation, where interference is delicate and isolation is rare. Bubble mosaics thrive in the macrophysics of expansion, where horizons divide communication and spawn causally sealed domains. Landscape logic thrives in the space of solutions, where equations admit many consistent vacuum choices. Holography thrives at the boundary of gravitating regions, where information bounds the number of possible states. None of these pictures cancels the others, because each asks a different question about abundance. What multiplies in one is outcomes, in another is spatial domains, in a third is vacuum options, and in a fourth is descriptions. Tensions remain. If branching already provides a complete unitary evolution, what is the status of bubbles from eternal inflation when described at the level of the universal wave function? If the landscape contains a staggering number of vacua, what principle governs measure across them, and how are probabilities defined when counts may be infinite? If holography encodes a bulk in boundary variables, does it compress the multiverse into a single grand code, or does it assign separate codes to separate regions? Each framework invites a different way to tally reality, and tallying is the delicate art at the center of every multiverse claim. Measurement of measure is the technical heart of the debate. In branching, a rule connects amplitude squared with observed frequencies, guiding expectations for outcomes within a single laboratory and within entire cosmological histories. In eternal inflation, volumes grow without end, so naive fractions become ill-posed, forcing careful regulators that prevent infinities from swallowing inference. In the landscape, different vacua may be reached by different dynamical pathways, each with its own weight, further complicating the census of worlds where observers can arise. In holography, the finiteness of boundary degrees of freedom offers a kind of discipline, suggesting that the number of independent states inside a region is bounded, shaping how generous reality can be inside any one causal diamond. Each program recruits different tools. Branching leans on quantum information, decoherence theory, and precise control of entanglement. Eternal inflation leans on high-energy cosmology, field dynamics in curved spacetime, and the statistics of primordial fluctuations. The landscape leans on geometry of extra dimensions, fluxes, and stability of compactifications. Holography leans on conformal field theories, entanglement entropy, and the remarkable equivalences that translate gravity into gauge dynamics. The convergence is not accidental. All four grapple with the fact that information and law can generate a richness that looks like plurality without breaking consistency. In practice, these roads can illuminate one another. Holographic insights constrain what kinds of gravitational worlds are consistent with finite information. That discipline feeds back into inflationary models and black hole physics. Branching clarifies how classical reality emerges from quantum underpinnings, which helps define when a cosmological fluctuation becomes a classical seed for galaxies. Landscape reasoning offers a stage where inflation can end into different vacua, linking early dynamics with later constants. No single road provides a complete map, yet the overlaps keep sharpening intuition. Conceptual discomfort fuels progress. Critics ask whether multiplying worlds rescues clarity or dissolves it. Supporters answer that the equations already imply plenitude, and that refusing it requires adding ad hoc rules. Skeptics of eternal inflation worry about predictability when everything that can happen will happen somewhere. Practitioners respond with refined measures and with searches for signatures such as gravitational waves or subtle imprints in the microwave sky. Doubters of the landscape ask whether a theory that allows so many vacua can be falsified. Proponents look for consistency conditions that exclude vast regions of the catalogue, turning a flood into a constrained atlas. Questions about holography probe whether the bulk emergence story extends beyond special spacetimes, and whether cosmological backgrounds share the same crisp duals known in highly symmetric cases. The most striking commonality is humility before information. Branching says reality is the full wave, not the slice an observer carries. Eternal inflation says a horizon hides most of what exists, leaving local fields to evolve without knowledge of the whole. The landscape says laws can be realized in many ways, and that what is measured may be a local chapter in a larger anthology. Holography says a region's content is capped by its boundary area, and that the deepest description may live on a screen only indirectly related to the space it defines. Each view elevates information from a passive record to an active architect. These frameworks do not require belief as comfort. They require careful attention to what equations insist upon and to what observations permit. A laboratory interferometer and a satellite that maps the sky are not enemies in this task. A theorem about entropy and a model of a scalar field are not strangers. The multiverse is not a single idea. It is a family of ideas born from the same refusal to add special exceptions to otherwise universal laws. Whether reality branches within one universal wave, blossoms into a garden of bubbles, explores a continent of vacua, or projects from a boundary code, the theme repeats with quiet persistence. Abundance is not decoration. It is a natural outcome of consistency pushed to its limits. The roads converge on a simple, unsettling proposal. The cosmos may be larger, not only in size but in description. What exists may be the full solution space of its laws, trimmed only by consistency and by the finite capacity of information to organize itself. That proposal does not end inquiry. It begins a more disciplined one, where each framework must earn its place by predicting patterns that telescopes, detectors, and careful reasoning can confront. The map is not finished. Yet, the intersections already reveal a terrain that is richer than a single path could ever suggest. Science reaches for invisible structures with hands made of instruments, statistics, and patience. When abundance hides behind silence, the first tool is coherence itself. Laboratories cradle supercooled chips, where qubits hum at microwave frequencies. Gates are applied in carefully timed pulses, then reversed to check whether the tiny waves of possibility recombine as perfectly as theory requires. If the interference is sharp and the phases return with high fidelity, unitary evolution has survived contact with the world. Error correction codes are layered on top, not simply to protect computations, but to witness a principle: information, once spread through entanglement, can be gathered again. The act of recovering a delicate quantum state reads like a small verdict that collapse is not a primitive act of nature. Consistency is measured by the quiet reappearance of a pattern that should have been lost if abrupt endings were fundamental. Another tool leans on weak measurement, a method that touches a system so gently that it only nudges the probabilities while preserving most of the interference. By repeating that touch across many trials and combining the results, experimenters reconstruct trajectories that traditional measurement would erase. The reconstructions do not reveal hidden variables. They reveal smooth quantum evolution under minimal disturbance. When combined with reversible dynamics, these gentle probes draw maps of how superpositions flow and separate before any outcome hardens into a record. In those maps, branching looks less like a jump and more like a steady drift from fragile overlap into robust distinctness. Molecules offer a separate proving ground. Colossal organic structures, thousands of atomic masses in size, are launched through vacuum chambers where gratings imprint phase differences. On the far wall, fringes appear or fade depending on how cleanly the motion is shielded from vibration, stray light, and residual gas. Every successful fringe at a larger mass scale tightens the net around theories that add intrinsic collapse. Competing models predict spontaneous kicks that would smear the pattern. The absence of such smearing restricts their parameters. Each new interferometer becomes a balance, weighing reality's taste for coherence against proposals that shorten the reach of superposition. The pointer slowly tilts toward a law that does not bow to size. Optomechanics extends the same question to tiny mirrors and trapped membranes. Laser light establishes superpositions of motion, pushing a mechanical element into two paths separated by less than a hair's width, yet distinct enough to interfere. Thermal noise and cosmic rays are enemies. Cryogenic staging and layers of shielding are allies. When the interference survives long enough to be seen, It adds another stone to a cairn built from repeated demonstrations that quantum behavior scales upward as far as engineering can carry it. Each stone narrows the room available to ad hoc endings. A different suite of tests stares outward instead of inward. Polarization maps of the ancient sky are combed for curling patterns that would betray primordial gravitational waves. Those waves would be the fossil roar of a field that inflated space, the same mechanism that naturally generates an ensemble of cosmic pockets. The signal looks like a faint swirl, a pattern that galactic dust can imitate with annoying charm. Observatories separate colors of light to distinguish true fossil curls from the local haze. Cross-checks between instruments and seasons become rituals of purification. If the swirl is found at the right strength and spectrum, it will anchor a story in which regions finish expansion at different times, a story that easily populates reality with domains beyond the horizon. Bubble collisions, if they ever occurred, could have brushed scars onto the afterglow. The telltale signs are disks or graded bands, where statistics depart from randomness by a whisper. Specialized algorithms scan full sky maps for such circles, all while guarding against false positives that noise and foregrounds love to produce. A single compelling disk would turn speculation into archaeology. Absence does not refute the larger framework, but presence would be decisive. For now, the search continues, learning from each improved data release how to separate chance from imprint. Spatial curvature is measured with exquisite care. Triangles on cosmic scales are constructed from standard rulers and candles, then checked for excess or deficit angle. A slight negative curvature could hint at a panorama broader than a simple flat patch. The bounds tighten with each catalogue of distant galaxies and each refinement in the distance ladder. The effort is meticulous because the signal, if any, is faint, and systematic errors can masquerade as curvature. Geometry, once a schoolroom exercise, becomes an instrument for asking whether space is an island or part of a larger continent. Gravitational wave observatories listen for a background that does not point to any one event. Black hole mergers sing like bells, but the multiverse would sound like surf, a stochastic hiss laid down by processes in the first instance. Spaceborne antennas, pulsar timing networks, and terrestrial interferometers each cover different bands of this cosmic radio. A detection with the right statistical shape would help choose among models for early expansion, indirectly tuning how generous the global picture must be. Upper limits, while less thrilling, still sharpen the story by excluding exuberant scenarios that would have filled the universe with louder relics. Quantum gravity may reveal its preferences through entanglement itself. Proposals to test whether gravity can carry quantum information use tiny masses placed close together and isolated from all other forces. If the masses become entangled only through their mutual attraction, then gravity has revealed a quantum character. That result would support frameworks where space-time itself is woven from correlations, and it would discourage ideas that treat gravitational influence as a classical whisper added on top of quantum rules. The experiment is fiercely difficult, requiring near-perfect isolation and timing, but its promise is clarity of principle rather than spectacle. Black hole thought experiments have migrated from chalkboards into controlled analogues using cold atoms and engineered Hamiltonians. By building small systems that mirror features of horizons and evaporation, researchers can watch information leave in a way that preserves unitarity. The Page curve, once an abstract prediction for how entropy should rise and fall during evaporation, gains empirical footing in platforms where entanglement entropy can be measured directly. The details do not claim to be literal black holes, yet the recovered information speaks to a universe that does not destroy the quantum record, a consistency that harmonizes with pictures where reality never discards branches, only hides them behind causal walls. Collapse models do not leave the stage without their own auditions. They predict faint X-ray glows from spontaneous localization or heating of ultra-cold systems beyond what conventional noise can explain. Low background detectors and delicately balanced cantilevers serve as ears for these predicted murmurs. As sensitivities improve, the allowed room for such mechanisms shrinks. A residual signal would be a revelation, restoring a hard ending to quantum possibilities. Silence, so far, accumulates as evidence that endings are emergent rather than fundamental. Cosmological surveys add a complementary weight through sheer statistics. The distribution of galaxies, weak lensing patterns across the sky, and the growth of structure over time encode the seeds that inflation stretched. Deviations from near Gaussianity, if established cleanly, would point to specific inflaton behaviors or to multiple fields at work. Some behaviors are friendlier to eternal expansion than others. Precision in these maps therefore flows backward into judgments about how varied the global cosmic tapestry is allowed to be. A subtler program studies measure not as philosophy but as a statistical discipline. When theories predict ensembles rather than single outcomes, inferences must be made with care. Regulators are crafted to tame infinities, then varied to ensure that conclusions do not depend on arbitrary choices. The same rigor used to extract a particle mass from a scattering peak is repurposed to extract meaningful statements from a distribution of possible worlds. It is not glamorous, yet it determines whether a framework can ever whisper numbers that instruments can chase. Neuroscience contributes a quiet analogy by building controlled illusions where perception flips between alternatives without external change. The flips are timed, the brain states are recorded, and the statistics are compared with quantum decision models. No claim is made that minds branch like wave functions. Instead, the goal is to test how observers weight probabilities when many outcomes are plausible but only one is experienced. Decision theory born in quantum contexts finds calibration in human choice data, reinforcing or refining the rules that connect amplitude with observed frequency. The bridge is conceptual, the tests are empirical. The frontier advances through repetition shaped into reliability. Interference is built, lost, and rebuilt in countless circuits. Sky maps are taken, cleaned, and retaken with better control of dust and instrument drift. Backgrounds are hunted down in gravitational wave channels until only the sky remains. Each success sharpens a picture in which the laws favor continuity over rupture. Each null result trims exuberant possibilities and elevates quieter, more disciplined versions of abundance. The methodology is simple to say and hard to practice. Isolate, vary, reverse, compare, and never trust a single instrument or a single statistic. What cannot be touched directly can still be tested by its shadows. If reality hosts more than one domain, the seams may leave patterns. If quantum law refuses to end abruptly, interference will return when coaxed. If gravity is built from entanglement, information will refuse to vanish at horizons. Evidence accumulates grain by grain until a mosaic forms. In that mosaic, the image that emerges is not fantasy dressed as science. It is a disciplined invitation to widen what counts as real, accepted only when patterns repeat under new light and new hands. Word count. 1186 est supérieur à, est supérieur à, est supérieur à, awaiting. Un. Bạn đã nói, bar, thiên văn 15 section đã nói. Section 8. A choice appears small. Press a button or let it wait, speak a sentence or keep the mouth closed, tilt a mirror or leave it straight. In the ordinary picture of chance, a decision faces a lottery and hopes for a favorable ticket. In a branching picture, the lottery never discards tickets. Every ticket is drawn somewhere, and a person becomes many versions who inherit different outcomes. Yet decisions still feel urgent, stakes still feel heavy. The puzzle is simple to state and difficult to settle. If every outcome happens, what does it mean to prefer one action over another, and how should a rational mind weigh the future? Probability, once treated as ignorance about a single result, must be recast as a measure over multiple heirs of the present. The mathematics names this measure with a familiar rule that squares amplitudes to produce numbers between 0 and 1, then normalizes them to unity. The rule predicts laboratory frequencies to exquisite precision, but prediction is not interpretation. The question reaches past experiments into meaning. Why should an agent caring about all of their future copies weight plans by those squared amplitudes rather than by branch count or some other tally? Decision theory steps forward like a quiet accountant. It does not argue about metaphysics. It asks which preferences can be coherent across splits. Imagine an agent who knows that a device will branch the world into many outcomes with known amplitudes, and who must set payoffs now for their successors to receive in each branch. If the agent tries to maximize the simple number of branches with good payoffs, trouble follows, because branching can be subdivided by arbitrary refinements without physical change. A measurement can be decomposed into many substeps that create extra records without altering total amplitude. Counting raw branches would then be manipulable by bookkeeping. Coherence demands a measure that remains invariant under such cosmetic rearrangements. Squared amplitude respects that invariance. Coherence also asks for non-contradiction across time. Suppose an agent embraces a rule today that conflicts with the rule they will endorse tomorrow after learning more. If those rules force them to accept sure losses through cleverly arranged gambles, the rule collapses under its own weight. Thought experiments of this type impose symmetry and additivity requirements that narrow the possible measures. Under mild assumptions about rational preference and consistency, the squared amplitude emerges as the unique weighting that avoids sure loss traps while respecting the structure of quantum events. The conclusion is not mystical. It is a translation from geometry into prudence. Another path to the same destination begins from symmetry in the physical description. When two branches can be swapped without changing anything observable, no preference should distinguish them. If a state can be decomposed into equal components related by such symmetries, the natural assignment gives each component equal weight. More complicated states can be built from these equal pieces, and the weights glue together with quadratic dependence on amplitude. The construction leans on invariance under transformations that leave the physical situation unchanged. Where symmetry rules, measure follows. A third line of reasoning treats probability as typicality. In a tall forest of branches, almost all versions of an observer will see frequencies that match the squared amplitude weights when experiments are repeated many times. There will be exceptional lines of history where frequencies differ wildly, but those lines are sparse with respect to the relevant measure. A rational agent, expecting to become typical among their many successors, anticipates the usual frequencies. The expectation is not a bet on a single path. It is a statement about the geometry of the whole, in which typical experiences dominate the landscape that matters. These arguments do more than justify a formula. They restore meaning to prudence. An agent does not shrink into fatalism because abundance exists. Preferences still shape what the bulk of their heirs inherit. Choosing a policy that maximizes expected value with squared amplitude weights increases the portion of successors who fare well by that standard. Each successor will call their outcome certain after the fact, but the pre-branch agent can still care about the distribution of well-being across successors before the split. Caring becomes a measure, not a tally. Ethics enters through this door with complicated shoes. If actions affect many branches, should an agent sacrifice a small amount of welfare in a high-weight branch to secure large benefits in low-weight branches? The calculus mirrors classical cost-benefit analysis, but transposes it into a multiverse key. The weights define how compassion scales across multiplicity. A policy that seeks to maximize weighted sum of goods will prioritize improvements that help large measure successors, even if a vast number of tiny measure lines receive less. Another policy might value equity across branches, elevating outcomes in thin measure corners to avoid extreme disparities. Both attitudes can be encoded in utility functions, but the arithmetic of measure remains the backbone that keeps reasoning coherent. Identity strains under this. If a person expects to become many, what binds those many into a single moral subject before the split? Memory, continuity, and psychological similarity suggest a lineage rather than an atom. The lineage cares across its offshoots. Like a gardener planning how water will divide among channels, the agent shapes the distribution rather than the singular result. Responsibility persists because policies can be judged by the landscape they create. Outcome ownership is replaced by stewardship of measure-weighted futures. Frequency still plays a role. Repetition in laboratories yields counts that converge toward amplitudes squared. Those counts do not prove an interpretation by themselves, but they anchor expectation. An observer who tries to interpret probability as branch count or as linear amplitude would predict different long-run frequencies in their personal experience, and almost all of their successors would find those predictions fail. Empirical success therefore collaborates with rational preference to select the correct weighting. The Webb tightens. Symmetry, coherence, and observation all point to the same scale. Objections persist and sharpen the picture. Some argue that decision theory presumes what it seeks to justify, smuggling the desired measure into its axioms. Others claim that typicality arguments assume the very weighting they conclude. These critiques force clarity. Each assumption must be named, that agents should avoid sure loss, that physically irrelevant refinements should not change preferences, that symmetries express indifference, that repeated trials generate concentration around expected frequencies. None of these statements mentions measure explicitly. Together, they leave little room for alternatives. The mathematics places limits on imagination. A theorem about how probabilities must behave over the set of all projection operators in a Hilbert space squeezes the possibilities until only the familiar rule survives, provided the space has enough dimensions, and the agent accepts additivity for exclusive outcomes. Technical conditions matter, but the spirit is clear. The structure of the state space dictates the weights that make sense within it. Choice, symmetry, and geometry conspire to deliver inevitability from abundance. Beyond the formalities, a human truth flickers. People act under uncertainty because attention is finite, not because the universe is undecided. Even in a world where every outcome occurs, the mind holds only one thread and must plan as if faced with a distribution. The weight on that distribution guides compassion for successors and discipline for risk. An investor hedges, a doctor balances treatment paths, a pilot trains for contingencies, not to dominate every branch, but to favor the swath where well-being is greatest by the right measure. Rational humility replaces control. The scale is acknowledged, then used. There is a softer insight as well. Abundance can feel like dilution, but it can also feel like responsibility enlarged. If many inheritances flow from one policy, care must widen. The rule that squares amplitudes is not just a statistic. It is an ethic of attention, a way to distribute concern among future versions without fear of paradox or exploitation by clever framing. A mind following this rule will not be tricked by artificial branch multiplication. It will not be coaxed into sure-loss gambles hidden in elaborate measurement trees. It will show patience when repetitions are needed and restraint when refinements are cosmetic. Wisdom becomes the art of honoring the measure that the world's geometry supplies. The weight of possibility rests on a simple balance. On one side lies the geometry of quantum states. On the other lies the coherence of preference and the testimony of repeated experience. The beam tilts toward a single rule that has guided experiments for a century and now guides prudence across multiplicity. Probability regains its meaning not as ignorance, but as a principled way to care for a family of futures. The small choices return with gravity. Press or wait, speak or stay silent, tilt or leave straight. Each act writes a policy into the branching book, and the scale that sums its consequences is not arbitrary. It is carved into the space where possibilities live. Gravity gathers light into knots and then hides what it has gathered. A star collapses, its core folding into a point that ordinary space cannot accommodate. Around the point forms a horizon, a one-way coast where even photons surrender their journey outward. From the outside, the horizon looks smooth. From the inside, the equations whisper of extremes. The puzzle that follows is not only about weight and curvature. It is about information, the quiet bookkeeping that counts states and preserves meaning. If information can never be destroyed, then a black hole cannot be a simple furnace that erases detail. Somewhere, in the language of quantum theory, a ledger must remain balanced. The ledger appears first as a number. A horizon carries entropy, proportional to its area measured in units that count tiny bits of geometry. The more area, the more ways the black hole can be microstructured behind its serene exterior. Temperature follows from entropy, so the horizon glows faintly with a thermal spectrum. Radiation leaks away, and the hole slowly shrinks as if it were a hot coal losing embers. The story is beautiful and troubling at once. Thermal glow carries little memory, yet the total evolution of quantum states should be unitary. If the glow were perfectly forgetful, information would vanish, and the laws that guard it would break. A clue turns the picture inside out. In some geometries, a region with gravity finds an exact partner description that lives on a boundary at infinity and has no gravity at all. The boundary theory counts, states, and evolves them without loss, and the counting precisely matches the entropy associated with horizons in the bulk. The boundary knows how many interior configurations are possible because the interior is not separate. It is encoded in correlations spread across the boundary. The canvas on the edge holds the script for the stage inside. Space-time becomes a projection, not in the sense of fiction, but in the sense of redundancy. The content in the volume is recoverable from information painted on the surface. Entanglement becomes the thread that stitches this picture together. Two parts of a quantum system may be isolated from outside contact, yet still share a single description that cannot be broken into separate lists. The intensity of that connection can be quantified, and in the gravitational partner, it is measured by the area of a minimal surface that hangs inside the bulk and anchors to the boundary region in question. Geometry is not only about length and curvature anymore, geometry starts to count relationships. The interior of a region is shaped by who is entangled with whom on the edge. If entanglement is the mortar, then wormholes hint at what the bricks can do. A wormhole is a tunnel that connects distant regions of space in a way that geometry finds consistent, although traffic through the tunnel does not outrun light in any exploitable manner. A curious proposal suggests that when pairs of particles are maximally entangled, their joint description resembles two mouths of a non-traversable wormhole. The letters stand for the equivalence of Einstein-Rosen bridges and Einstein-Podolsky-Rosen correlations. The first is a geometric link, the second is quantum entanglement. Together they suggest that the two languages describe one structure from different sides. This proposal does not turn teleportation into science fiction. The tunnel cannot be crossed with a ship. Instead, it serves as a metaphor with teeth for how information can remain unified while appearing separated by distance or horizon. When two black holes are prepared in a shared quantum state, the combined system has an interior that looks like a throat joining them, at least in certain regimes. The cartoon is not fanciful. It guides concrete calculations about how signals that respect causality can nonetheless be reconstructed by observers with the right access to correlated data. The ledger of information comes back as a curve. If a black hole emits radiation in a unitary way, the entanglement entropy between the radiation and what is left behind should rise at first, then reach a peak, then fall as the whole finishes evaporating. This shape is called the Page curve. For a long time, the tools to derive such behavior from gravity were missing. The counting could be done on the boundary, where unitarity is guaranteed, but translating it to the bulk needed a new ingredient. That ingredient arrived through the idea that quantum extremal surfaces, cousins of the minimal areas used earlier, must be included when computing entropy in gravitational settings. These surfaces can jump in location as the radiation accumulates, and the jump signals a transfer of encoded information from the interior to the outside description. The falling branch of the curve emerges. The ledger balances without tearing the page. Paradoxes argue back. If radiation carries detailed information out, an observer who falls into the hole should encounter a smooth horizon, while an observer who stays outside and decodes the correlations should conclude that the interior degrees of freedom have been consumed. The tension is sharp. One way through relies again on the careful allocation of entanglement. The interior is not an independent warehouse of qubits. It is a particular assembly of correlations that can be reconstructed by different observers with different tools, so long as they respect causal limits. There is no single catalogue that all observers can access at once. Each catalogue is correct within its domain, and consistency is enforced by the rules that prevent comparisons that would require forbidden signals. Quantum error correction enters as more than an analogy. The way bulk information is stored in the boundary resembles how a message is distributed across many physical bits so that errors can be corrected when part of the system is lost. The interior of a simple gravitational region can be reconstructed from several overlapping boundary subregions, just as a protected logical qubit can be recovered from many different subsets of physical qubits. If some boundary pieces are erased, recovery still works as long as a threshold is met. The code does not live in a laboratory device alone. It lives in the way gravity insists that the number of independent states inside a region is bounded by the area of its rim. The bound is like a budget, and the code is the strategy for spending it without losing critical content. Clues accumulate in engineered systems as well. Small quantum devices are wired to evolve under dynamics that imitate simplified gravitational models. Entanglement spreads, thermalizes, and then reveals strange revivals when specific correlators are measured. The revivals echo the idea that information, while scrambled, is not destroyed. Circuits tuned to create entangled pairs and then to apply controlled couplings produce patterns that match predictions derived from wormhole-inspired calculations. Nothing supernatural occurs, only correlations reorganized in clever ways. Yet the mirroring of bulk concepts in tabletop experiments strengthens the intuition that entanglement is not an ornament. It is a load-bearing beam. If spacetime can emerge from entanglement, then the absence of entanglement should pull geometry apart. Regions decohere when they lose overlap in their global description. In the same spirit, bulk neighborhoods that cease to share sufficient correlations lose the smoothness that would otherwise connect them. The picture suggests that continuity is a collective property, a macroscopic illusion built from a dense web of microscopic ties. Gravity, then, is not only curvature responding to mass and energy, it is also the tendency of information to organize itself into shapes where distances and horizons make sense. This view reframes singularities. Where equations diverge, the emergent description breaks down, not necessarily because nature hits a literal point, but because the web that gives rise to geometry has been stressed beyond the regime where a continuous picture holds. New variables may become appropriate, just as the language of sound waves fails when air thins and one must count molecules instead. The interior of a black hole, seen in this light, is not empty. It is a region where the code that spells out space stores data in a way that keeps outsiders locked away from the details unless time and access permit a different assembly. Skeptics are right to ask for care. Pictures can seduce, and metaphors can overreach. Yet the chain from horizon area to entropy, from boundary dynamics to bulk encoding, from entanglement to surface areas, from coding to reconstruction, from wormholes to correlators, is more than a sequence of slogans. It is a network of calculations that check one another. Each piece on its own would be suggestive. Together they form a scaffold sturdy enough to work on. Work continues because puzzles remain. How far beyond special geometries does the dictionary between bulk and boundary extend? How do cosmological spaces that keep expanding find their clean duals? What principles fix the precise code that space uses to protect its interior? The old image of gravity as a single force becomes a chapter in a larger book where information moves the plot forward. Horizons are not merely edges that trap light, they are screens that count states. Wormholes are not shortcuts for travel. They are diagrams for how correlations knit distant systems into a single lawful object. A black hole is not a destroyer of detail. It is a patient scrambler that returns what it received as properly coded radiation over long time. The ultimate lesson is gentle. Space is not a stage set first and then filled. Space is a pattern in the music of entanglement, and gravity is the rhythm that keeps the pattern in time. A handful of numbers guide the behavior of matter and light as if they were tuning pegs on a silent instrument. Twist one slightly, and stars would not ignite. Twist another, and chemistry would never lift itself from monotony. The fine structure constant, a dimensionless ratio that sets the strength of electromagnetic interaction, sits near 1/137. The proton to electron mass ratio hovers close to 1836. Gravity is so weak compared with the forces inside nuclei that it seems almost ceremonial, yet its patience sculpts galaxies and steadies stellar lives. The vacuum of space carries a tiny but non-zero energy density, a cosmological constant so small that it is difficult to express its tininess without losing meaning. These values give the cosmos a usable temperature and a stable clock. If they had been very different, attention would not have arisen to ask about them. The sensitivity is not a rumor whispered by romantics. Nuclear physics builds a pathway from hydrogen to carbon and oxygen through resonances that happen to lie in just the right places. Carbon forms in a triple step inside red giant cores, a delicate choreography that would be disrupted if the strong force were a little weaker or the electromagnetic repulsion a little stronger. Stable nuclei depend on balance. Too much strength and everything fuses into heavy clumps. Too little, and the periodic table collapses back into hydrogen and helium. Planetary systems require a gravity gentle enough to allow disks to settle yet decisive enough to condense worlds. The leash on each constant has length, but not infinite length. The leash holds within bands that look thin when plotted against all possibilities the equations might permit. These facts invite a quiete question. Are the values accidents fixed by the earliest moments with no explanation beyond initial choice? Or are they samples from a larger ensemble where variation is common and observers arise only within a narrow range? Selection enters not as mysticism, but as arithmetic. In a vast set of domains, almost all places remain sterile. A sparse subset generates heavy elements, complex chemistry, long-lived stars, and temperatures that allow slow experiments called life. Any being that measures constants will find itself in the subset where measurement is possible. The observation is not a prediction by itself, it is a consistency condition that filters expectations. Within this frame, the puzzling smallness of the cosmological constant softens. If vacuum energy were much larger and positive, space would accelerate so quickly that matter could never assemble into galaxies. If it were large and negative, the universe would recollapse before structure had time to form. The permitted window is narrow when measured against natural naive guesses. A population of domains with many vacuum energies would produce observers only where the value sits inside this narrow band. Finding a small constant then becomes unsurprising, not because it is inevitable, but because surprise cannot exist in domains without astronomers to feel it. The lens of selection reframes other quantities as well. The ratio of gravity to electromagnetism controls the sizes of stars and the stability of planets. A stronger gravity shrinks stars and speeds up their lives. A weaker gravity spreads gas so thin that nuclear burning barely starts. The charge of the electron, the masses of the light quarks, and the overall strength of the strong force together determine whether atoms bind with useful variety. In an ensemble of domains with many parameter values, the great majority would be barren deserts. Habitable oases would be rare but inevitable within the total landscape. The logic earns skepticism because it can feel like a retreat. If everything happens somewhere, any observation can be waved away as a result of living where it happens. Discipline is required to prevent that slide. Selection reasoning must live inside a theory that already predicts an ensemble, and it must be tethered to measures that assign weights to different domains. The weights determine which kinds of regions dominate the census of observers. Without a measure, the word typical has no teeth. With a poor measure, contradictions breed. The art lies in defining a cut through infinities that does not depend on arbitrary choices or on data smuggled in after the fact. Even with care, paradoxes knock on the door. In some ensembles dominated by continued expansion, thermal fluctuations at late times can produce transient observers that never evolved from stars or biology. These hypothetical entities, called Boltzmann brains, would outnumber ordinary observers if the expansion lasts forever and if the production rate, however tiny, never halts. Predictions would then be ruled by bizarre late events rather than by the structured histories felt by living beings. To avoid this fate, the cosmological model must either end expansion in a way that limits such fluctuations or set parameters so that the ordinary evolution of galaxies produces the dominant set of minds. The requirement becomes a constraint, not metaphysical but statistical. A second challenge concerns variance. If domains differ widely, how similar should two randomly chosen habitable regions be? Some constants could vary only a little across the subset that allows life, while others could span a generous range. Observations that sit at extremes of the allowed range might strain the ensemble story, while values near the middle of the permitted band would be more natural. The argument becomes quantitative, when models propose distributions for the constants. The measured numbers are then data points that favor some distributions over others. Selection is not a license to stop. It is a program that demands sharper predictions about spreads and correlations. Observers are not simple to define either. A proton does not observe. A bacterium might, depending on whether observation is defined as interaction or as reflective awareness. To remain conservative, many analyses refer to proxies for habitability. They use the existence of long-lived stars, the abundance of carbon and oxygen, the availability of liquid water, the capacity for complex chemistry. These proxies are not perfect, yet they are safer than importing contested definitions into physics. The hope is that gross features of the constants can be constrained by coarse proxies in ways that do not depend on the subtleties of consciousness. The texture of time also matters. An ensemble may produce many habitable domains, but if most of them are short-lived, selection changes. Agents are more likely to arise where time is generous. The density of supernovae, the rate of gamma-ray bursts, and the metallicity of galaxies all influence safety and resource availability. The cosmological constant itself modulates star formation history, and hence the window of opportunity for life. In some models, there is an optimal order of magnitude for structure growth, not too fast and not too slow, that maximizes the production of long-lived, quiet star systems. The observed value sitting near such an optimum would lend weight to selection-guided expectations. There is also simplicity to be weighed. A fundamental derivation that fixes constants uniquely would be elegant. If such a derivation exists and is consistent with all else, selection becomes decoration rather than necessity. Absent that derivation, ensembles arise naturally from mechanisms already under consideration. Inflation that never fully ends, vacuum landscapes arising from many topologies and fluxes, or repeated cycles that sample different minima of potential energy, each carry multiplicity without being invented for this purpose. In these settings, selection is not a preference, it is an unavoidable lens through which any observer framed by one domain must look. Care extends to language. Fine-tuning does not imply purpose, it records sensitivity. A radio that picks up a clear signal only when the dial sits within a narrow interval is tuned because physics constrains resonance, not because the device wants to be understood. The cosmos, similarly, could host life only within limited bands of parameter space without implying that it was arranged. The word rare does not mean forbidden, it means unlikely under naive counting. A theory that multiplies trials changes what unlikely looks like. The anchor remains prediction. If ensemble ideas and selection jointly yield constraints that match telescopes and laboratories, they earn their place. A quiet ethical undertone accompanies the statistics. If a domain is one oasis among deserts, its resources are not sacred because of cosmic intention, they are precious because they are not guaranteed elsewhere. The scarcity reframes responsibility. Care for a planet becomes practical rather than sentimental. Within this frame, humility grows alongside gratitude, not because an external will commanded it, but because the arithmetic of rarity makes recklessness look unwise. The numbers persist whatever philosophy attends them. Electromagnetism holds to its quiet ratio. Gravity continues its whisper. The vacuum continues its near-perfect shyness. Hydrogen still fuses in shells deep within aging stars, and carbon still fills interstellar clouds with its patient possibilities. The instrument stays in tune because the pegs sit where they sit. Whether those positions are one draw from a single urn, or the typical draw from a vast basket of urns, remains an open question. Selection does not answer it alone. It steadies the hand while better explanations are sought. It guards against naive astonishment and against lazy acceptance, reminding thinkers that any measurement is made by a being embedded in a narrow slice of a larger space of possibilities. In that reminder, bewilderment acquires a frame that allows wonder to remain and work to continue. A vast sea may touch the hull without leaving a mark, yet sometimes a current scratches a story into the wood. The sky carries its own hull, a shell of fossil light cooled to microwave hush. If neighboring realms ever brushed against this realm when space was young, the contact could have pressed faint signatures into that hush. The search for such testimony asks the oldest light to confess its secrets. and the youngest instruments to hear whispers almost erased by time. The simplest scar would look like a circle. Imagine two inflating domains expanding side by side until their edges met. The collision would propagate as a spherical disturbance into each region, freezing a gentle disk into the background once photons decoupled from matter. The center of the disk would point to the direction of encounter, and the temperature inside might slope ever so slightly, warmer on one side, cooler on the other, with polarization lines curling in a pattern too orderly to be chance. No single circle would prove a neighbor. Noise makes imitations. Dust in the Milky Way paints swirls that pretend to be the cosmos. The work therefore becomes statistical and aesthetic. Algorithms sweep over the whole sky, fitting concentric templates, comparing likelihoods, and penalizing false discovery. A true disk would survive rotations, data splits, and frequency changes. A false disk would wilt under such discipline. A more jagged sign would be a wall. Domain walls form when a field can rest in more than one vacuum, and different regions choose differently. If a wall crossed the visible universe in the first moments, it could have left a broad gradient in the afterglow, or a discontinuity smoothed by later expansion. Unlike a circular collision imprint, a wall's trace would stretch across great arcs with a geometry that refuses to align with galactic clutter. Polarization would carry a telltale alignment, and lensing of background light by the wall's mass would bend distant galaxies in a pattern that standard structure growth cannot mimic. The challenge lies in disentangling subtle, coherent signals from the forest of ordinary fluctuations that already jostle the map. Cosmic textures offer a third possibility. These defects unwind rather than persist, but while they live, they focus and defocus light, creating hot and cold spots with profiles sharper than typical random peaks. A single texture is an anecdote. A population with the spectrum predicted by a particular field theory becomes a hypothesis that can be weighed. Wavelet transforms and matched filters pull characteristic shapes from the noise and ask how many live where chance would rarely place them. If the count exceeds randomness across independent surveys, the case strengthens. If not, bounds tighten on models that would have filled the sky with sharper knots. The faint curl of polarization known as B mode is another ledger. Gravitational waves from the earliest instance would twist polarization into a swirling pattern with strength that rises and falls across angular scales according to a calculable recipe. Bubble collisions would add their own twist, not as a smooth background but as localized patches with edges. Instruments that separate the sky by frequency can subtract foreground dust, which produces its own curls by aligning grains with magnetic fields. What survives that subtraction and passes cross-checks between seasons and detectors speaks to processes that no galactic dust cloud can imitate. A pattern that matches the stamp of bubbles would be as decisive as a fossil with anatomically impossible joints. Spectral distortions widen the palette. The ancient light is nearly a perfect blackbody, yet energy injections long after photons parted from matter can warp that shape into faint deviations. Collisions of domains, decays of defects, or dissipation of small-scale perturbations can leave Y distortions or mu distortions, each with a distinctive frequency curve. Space-based spectrometers watch the microwave background not as a map, but as a spectrum, and ask whether the glow departs from perfection by the tiniest amount. A non-zero distortion, correlated with certain angular features, would tighten the net around exotic early events, and could even timestamp them. Gravitational waves carry information that light cannot. A collision between domains or a first-order phase transition in a larger landscape would launch a background of ripples with a peak frequency set by the energy scale and by the speed of the bubble walls. Different bands of detectors listen for different choirs. Terrestrial interferometers hear higher notes. Space-based observatories listen lower. Pulsar timing arrays feel the lowest drumbeats through correlated delays in radio flashes that cross the galaxy. A consistent signal with the right spectral slope and polarization could be traced back to an event that predates any star and exceeds any supernova in scale, yet leaves only a whisper today. Geometry itself can testify. If collisions occurred often enough to nudge global curvature, the largest observable triangles would sum to a value slightly different from flat. The deviation would be small and of definite sign in certain scenarios. Triangulation with standard candles, standard rulers, and gravitational lensing turns the cosmos into a classroom exercise done with ruthless care. Bounds on curvature already sit close to zero. A non-zero measurement would not immediately point to neighbors, but combined with other anomalies, it would refine the plot. A more recent messenger is the hydrogen fog that filled space before the first stars lit. The spin-flip transition at 21 centimeters allows radio telescopes to map this fog across time. A bubble collision or long-lived defect could have seeded over or under densities that alter how this fog absorbed or emitted against the microwave background. Three-dimensional maps of that line, if cleaned of terrestrial interference and ionospheric tricks, transform the early universe into a volume where relic structures can be hunted with tomographic patience. Cross-correlations of these maps with microwave temperature and polarization sharpen claims and reveal imposters. Lensing of distant galaxies by the distribution of mass between them and the observer offers another avenue. While ordinary structure growth produces a smooth statistical lensing field, a relic wall or a decayed texture would add a coherent, low-order deformation across a broad patch. Surveys that measure billions of galaxy shapes extract the weak signal by averaging away the randomness of orientation. If a broad, gentle shear aligns with a line seen in background polarization or with a spectral distortion gradient, coincidence becomes costly, and history begins to look specific rather than generic. Analysis fashions must follow humility. The sky provides one sample. Cosmic variance limits certainty on the largest scales because there are no other skies to compare. That limit can be mitigated by combining multiple traces that respond differently to the same cause. It can be respected by avoiding overfitting and by demanding that detected features repeat in split maps and across instruments. Simulations play the role of rehearsal. They inject artificial collisions and defects into synthetic skies and teach analysts how success and failure look under controlled conditions. Blind challenges prevent bias from planting its own circles where only noise lives. Technology pushes the horizon of subtlety. Detectors cool closer to absolute zero to hush thermal chatter. Optics sharpen to reduce beam systematics that turn constant signals into false patterns. Polarization calibrators rotate with metronomic certainty to keep angle errors from forging fake curls. Data pipelines track every transformation from raw voltage to final map, leaving a trail that can be audited. Collaboration culture shifts toward verification by independent teams who share nothing but sky and standards. The goal is not romance. The goal is plain competence, facing an extravagant hypothesis. Suppose a disk appears that survives every test. Suppose a shear aligns with it and a mild Y distortion crosses its face. Suppose no known foreground can account for the concurrence, and simulations of random skies rarely imitate such harmony. The case would still demand caution, but it would also demand curiosity with new energy. The next steps would involve predicting companion features, identifying optimal patches for deeper scans, and asking whether the implied collision parameters fit comfortably within inflationary dynamics. A single compelling pattern would not end debate. It would begin a new discipline of cosmic forensics. Silence remains a result as well. Each null detection slices away exuberant models and leaves leaner ones standing. The absence of scars does not silence the possibility of neighbors. Separation could have grown so vast that encounters were rare within our observable shell. Walls may have been too light to leave lasting marks. Gravitational waves may hum below current sensitivity. Even so, the pursuit teaches the craft of attention. It hones instruments, refines statistics, and deepens humility before an object that is both singular and potentially plural. The sky waits without urgency. Light from a time when atoms first formed continues to cross the darkness and pool in detectors. Patterns that look like stray brushstrokes might be dust, or they might be history reaching across void to write a single word. Whether that word is yes or no, the act of listening shapes the mind that hears it. A shell of old photons, a spectrum close to perfect, a field of faint curls and dots, these are the pages. Somewhere on those pages, a neighbor may have left a thumbprint. If it is there, patience will turn it up. If it is not, patience will say so clearly. Either way, the search draws a circle around what counts as evidence and teaches how small signs can speak for a large reality. Night rearranges chemistry. As eyelids close, the ratio of neuromodulators tilts. Acetylcholine rises in the dreaming stage, and norepinephrine and serotonin step back, as if a theatre crew has shifted the gels over the lights. Thalamic gates change their posture. The cortex slips into slow waves that roll like weather across a continent, then into rapid bursts when eyes flicker in their sockets. The brain alternates between long, quiet valleys and brief, storm-lit plateaus. In those valleys, synapses rest and rebalance. In those plateaus, images arrive without permission, a swift river of scenes that obey their own logic. The sleeper is a witness carried along. Hidden within those rhythms lives a fragile arithmetic of possibility. Neurons do not compute with coins or dice, they compute with thresholds. A single excitatory volley can push a population toward firing, but whether the surge crosses the line depends on timing, noise, and the shape of the network. When millions of units share that balance, collective events appear. Researchers call them neural avalanches. A small fluctuation can travel far, yet the system does not explode because inhibition culls the wave. At the edge between quiescence and runaway activity, the brain gains sensitivity. It can respond to fine differences in input, then settle again. Sleep steers the brain across that edge, with a patience evolved over ages. Dreams look like narratives because the brain is a prediction machine. By day, sensory streams anchor the model, forcing it into alignment with the outside. By night, input gates soften, and the model runs itself. Hippocampal networks replay paths through remembered rooms and streets. Neocortical assemblies flex their associations, stitching new bridges between items that once seemed far apart. The chemistry favors plasticity. Signals strengthen or weaken based on timing. The result is rehearsal and repair. Memories are consolidated, fevers of emotion are lowered, and weak connections that do not help are pruned. None of this hints that brains are quantum computers. The warmth and wetness of biology drowned delicate superpositions before they could matter. Yet the language of branching still helps, not as a claim about physics inside neurons, but as a metaphor for cognition under uncertainty. A predictive brain must entertain many hypotheses in parallel. Each hypothesis is a candidate future where the next sensory pulse will make sense. During perception, those hypotheses compete and cooperate until one dominates. During dreaming, they unfurl more freely, untied from the strict checking that waking demands. The mind becomes a garden of counterfactuals, grown under the moon of its own chemistry. Perception itself carries a hint of multiplicity. Present an ambiguous figure, and the experience flips. A vase becomes two faces, then returns to a vase. Present distinct images to each eye, and awareness alternates between them. This rivalry is not a gradual blend, it is a switching of interpretations that feels sudden. In cortex, populations that support one interpretation suppress their rivals, then fatigue and release them. The timeline resembles a system wandering among basins in a landscape of possible meanings. Noise nudges the wanderer from one basin to the next. Attention biases the slopes. A model called predictive coding uses this landscape to compute. It treats perception as inference, then tunes the brain to minimize the errors between prediction and input. In sleep, the error terms relax, and the priors play, widening the catalogue of alternatives the system can represent. When a person dreams of walking through a city that never existed, the brain is testing edges, not reality. It recombines elements, lifts a building from one memory and a streetlight from another, places them beneath a weather that belongs to neither. The recombination is not art for its own sake. It searches for structures that compress experience into simpler rules. Compression lowers surprise in the long run. The next morning, a problem at work may feel less jagged because the dream explored a dozen wrong fits and one promising fit, then folded that candidate into the prior model. The logic is algorithmic. Explore, score, update, sleep again. This process needs silence. The daytime stream of sights and sounds would drown the subtle exploration. Sleep protects the computation. Slow waves gate information flow between regions, synchronizing plasticity windows so that change occurs where it helps and not where it harms. The hippocampus pulses at its own pace, sending compressed summaries to cortex during non-rapid eye movement stages. Later, in the flickering of rapid eye movement, cortex plays the lead and the hippocampus listens. The conversation loops for hours. It is not mystical that insights follow rest. It is architectural. The parallel with branching gains, texture from risk, choice under uncertainty, is a story both for agents in a multiverse and for networks of neurons. A person must pick policies that will feed many future selves scattered across outcomes. A brain must pick policies that will serve many future sensations scattered across environments. In both cases, wisdom does not bet everything on a single path. It distributes concern. Sleep refines this distribution by sampling a wider space of imagined contingencies, then reshapes synapses so that tomorrow's quick decisions are less brittle. Ethics enters the chamber quietly. If the mind rehearses not only what was, but what might be, it can practice kindness before the moment asks for it. A dreamed apology will not travel backward in time, but it can prepare the motor patterns for a real apology that daylight will require. The rehearsal strengthens circuits that embody patience, generosity, and restraint, so that a reflex today is less sharp than yesterday. The substrate is biological. The consequences are human. Emotions use sleep as a kiln. Fear and anger can crack when fired too fast, so the brain slows their cooling across cycles. The amygdala still lights during vivid dreams, but the prefrontal reins are looser, allowing new associations to wrap around old pains. The next day, a scene that triggered panic may still command respect, yet the body does not shake. The system has rewritten thresholds, not to forget, but to avoid flooding. The result is resilience that grows without blunting sensitivity. The feeling of self also shifts. During dreams, ownership of action becomes slippery. A figure in the dream speaks with a familiar voice, then with a stranger's urgency, and both feel true. Neuroimaging points to changes in networks that support metacognition. Monitoring circuits that tag thoughts as mine or not mine speak more softly. The boundary is porous, that porosity can be healing. A rigid self can trap sorrow. A flexible self lets sorrow move and drain. The next morning, the narrative of who suffered and who acted can be told with more air between the sentences. None of these features need a cosmic frame to matter, yet the cosmic frame casts a steady light. A universe that allows many outcomes because its laws are generous finds an echo in a mind that allows many narratives because its architecture is generous. The echo is not identity, it is resonance. A small system built from cells explores alternatives in a chemical night. A large system built from fields explores alternatives in a physical day. Both rely on coherence where it can be sustained and accept separation where it must occur. Both use memory to stitch fragments into story. The tools that study these processes share a family resemblance. In physics, interference and decoherence mark the line between delicate possibility and robust outcome. In neuroscience, synchrony and desynchrony mark the line between expressive exploration and actionable decision. In both, information flow is the currency, and networks are the market where value is assigned. The equations differ, the scales differ, the metaphors differ, yet the habit of mind required is the same. Track correlations, respect limits, and let patterns speak when they repeat. A final image brings the scales together without confusing them. Picture a river splitting around an island and then rejoining downstream. The split leaves a memory in the pattern of eddies. In the brain, a dream is such a split. Thoughts separate into branches of narrative, then return to a quieter channel by morning, their passage recorded in slightly changed banks. In the wider world, quantum events split descriptions into lines that do not rejoin, their differences preserved beyond recall. The river does not pretend to be the ocean. The scene remains a metaphor meant to guide attention, not a proof meant to insist. Morning arrives, the chemistry tilts back, thalamic gates open wider. the predictive machine reconnects to the stream of light and sound. Some dreams vanish at once, others leave an afterglow that colors choices at breakfast. The mind steps onto a day shaped by a night that felt like drifting, yet was, in fact, work. The work was to explore alternatives, to prune some, to reinforce others, and to teach the body how to move a little more wisely through uncertainty. Across the planet, in millions of rooms, that work continues each night. The result is not certainty. The result is a readiness to meet possibility with a steadier hand. A lamp of conscience burns, even when theory multiplies outcomes. A person stands before a choice and feels weight collecting in the chest, not as superstition but as a recognition that actions distribute consequences across many futures. If reality permits more than one line to unfold, morality does not evaporate. It changes its arithmetic. The question becomes how to care for a family of successors who will inherit different rooms in the same house of law. Responsibility begins with policy. An action is a policy enacted once, a rule chosen under uncertainty that shapes distributions rather than singular events. In a world that respects measure, the right guide is to favor the outcomes that occupy the largest share of weighted futures, while remembering that thin slices still matter when they hold extreme harms. Ethics becomes a careful balance between efficiency for the many and protection for the vulnerable. That balance is not sentimental. It is geometry turned into compassion. Praise and blame must be rewritten with that geometry in mind. Success in one thread does not cancel harm in another, yet praise belongs to policies that raise the average well-being by the correct weights and that guard against catastrophic tails. Blame attaches to policies that chase thin personal gains while pushing heavy cost into broad regions of measure. A leader who chooses safety standards that slightly slow profit but prevent rare disasters in a large fraction of futures earns a different moral standing from one who ignores those rare disasters because they do not always appear. The first sees distribution, the second stares only at a single path. Regret becomes a practical tutor rather than an absolute judge. After a split, each heir feels certainty about their history. Some will celebrate, some will mourn. The originator can still evaluate the policy against the distribution it produced. Regret teaches that a good choice may yield pain in some lines, and a bad one may look brilliant in a few. Wisdom is the knack for asking whether a policy would be chosen again before the split, armed with the same information, aiming at the same weighted kindness. The test resists the flattery of narrow victories. Altruism expands under multiplicity. Charity is not a coin tossed toward a single outcome. It is a shaping of many. The act of wearing a mask during an epidemic, the decision to keep a promise that costs time, the patience to slow a car at a crosswalk, each tilts a distribution toward fewer harms across a wide measure. The satisfaction that follows is not the glow of certainty. It is the quiet recognition that most successors will see gentler streets. In thin lines where misfortune still arrives, compassion turns outward rather than inward, because the policy tried to shelter them even when the wind did not cooperate. Justice asks how to treat wrongs when every possibility is realized somewhere. The answer is not to shrug. Institutions must protect the broad share of futures while honoring the dignity of individuals who find themselves in the unlucky rooms. This means proportional penalties that deter policies with dangerous tails, restitution that restores where restoration is possible, and reforms that reduce the share of branches where injustice repeats. The language shifts from punishment for its own sake to prevention and repair. A system that increases safety for the many while avoiding cruelty in the few is more moral under multiplicity than one that salves outrage in one thread and breeds harm in 100 others. Risk ethics takes center stage. Catastrophic possibilities with low weight still demand attention because even a small measure multiplied by a vast harm can outweigh modest gains spread widely. A planner must refuse gambles that generate slivers of ruin that debt future heirs beyond recovery. At the same time, the planner must avoid paralysis. All action has tails. The art lies in reducing tails that cut deep, while accepting small ripples that the world can absorb. Precaution then becomes targeted rather than total, guided by models that track who is hurt, how severely, and how many successors inherit the wound. Honesty acquires a new urgency. Deception can shift burden into unseen places, making one line of history look clean while another carries the cost. If a company hides a pollutant by exporting it to a poorer region, the action increases harm across a large measure while concentrating visible benefit in a narrow band. A measure-aware ethic condemns such trade-offs. Transparency protects against the laundering of pain. Disclosure is not merely a contract for a single world, it is a practice that prevents theft from cousins the agent will never meet. Personal virtues become strategies that stabilize the distribution. Patience dampens the impulse to chase thin wins that risk thick losses. Courage accepts present discomfort to avert broad damage later. Temperance reduces appetites that push externalities outward. Generosity spreads resilience across successors who would otherwise be brittle. Humility keeps models open to revision when evidence arrives that the distribution is not as kind as hoped. None of these virtues rely on metaphysics. All of them translate to rules that improve outcomes in the largest share of futures. Forgiveness fits carefully into this calculus. When harm occurs, some heirs will cry out for vengeance that spills more harm into neighbors. Forgiveness does not erase responsibility. It chooses forms of accountability that halt further damage. Restorative practices that compensate victims, rebuild trust, and reduce recurrence can outperform retribution that satisfies a wish in one line and multiplies suffering elsewhere. The goal is not to look away from wrong. The goal is to prevent wrong from radiating. Collective action faces a familiar trap. If each agent chases a private advantage, the distribution can degrade for everyone. The solution remains coordination. Agreements, norms, and law realign incentives so that individual choices add up to a kinder pattern across measure. A carbon price that internalizes cost, a safety code that removes cheap shortcuts, a norm that praises restraint, each moves the center of mass for many futures. The mechanics echo biology and economics, yet the motivation broadens. One does not play for a single victory. One plays for a field where most players in most lines find room to breathe. Technology amplifies these stakes. Algorithms that guide resources, autonomous systems that make split-second judgments, platforms that transform attention, all act as policy engines. Their objectives must be tuned to measure aware values, optimize only for average performance, and thin fragments with heavy loss will be ignored until they accumulate into scandal. Constrain objectives with fairness terms and safety margins, and the system favors designs that do not harvest success by sowing rare disasters. Testing must probe tails, not only means. Deployment must include fail-safes that cut off policies when signals of catastrophic branches begin to grow. Meaning does not vanish, it changes shape. A person who plants a tree may never sit in its shade, yet many successors will, and the act is judged by that spread. A teacher who spends an extra hour with a struggling mind tilts the distribution of futures where that mind finds an opening. A voter who weighs long-term harms over short-term ease participates in a quiet arithmetic of kindness. Life remains a series of finite acts performed under incomplete knowledge. Morality is the craft of making those acts serve the broadest set of inheritors without erasing the face of the single person standing in front of us. There is one more thread, quiet and difficult. Self-care is not selfishness inside this frame. A policy that destroys the agent in a large fraction of branches to rescue a thin sliver of others may look noble in a legend, yet it fails the arithmetic that values many lives, including the agent's heirs. Sacrifice can be moral when it removes catastrophic tails, or when it protects irreplaceable goods. It becomes less moral when it simply moves pain from one thin corner to another, while cutting down the tree that would have sheltered many. Courage remains vital, but it must be guided by clarity about consequences across measure. Language must adapt. Words like always and never harden in mouths that forget distribution. Better phrases invite nuance. In general, for most futures, unless preventing catastrophe, aim here. Such phrasing is not weakness. It is fidelity to a reality that does not reduce to a single line. Ethical rules become maps with contours rather than straight roads, and learning to read them is part of growing up in a world that allows plurality without surrendering meaning. Conscience, at the end, is a compass for distributions. It points toward policies that help the many, protect the few from ruin, and avoid debts that descendants cannot repay. It invites honesty, patience, courage, temperance, generosity, and humility, not because they look handsome in old books, but because they are control systems for a complex world. The lamp does not dim when possibilities increase. It brightens, asking for a broader field of view and a steadier hand. The person standing before the choice breathes, remembers the family of futures waiting, and acts so that most of them are gentler. A life unfolds like a score written for many instruments that will never meet in the same room. The notes are simple in isolation: a phone call returned, a cup set on a table, a promise kept. Each choice draws a line through a space of possibilities, and that space does not go dark when one line is taken. It remains, a quiet lattice of unrealized paths, present as context, even when unseen. Living Well asks for a posture that acknowledges the lattice without being paralyzed by it. The art is to move with attention, to aim policies rather than chase single outcomes, to carry hope that does not depend on certainty. Planning becomes a conversation with distributions. The planner sets targets with buffers, not because failure is expected, but because variability is honest. A small company spreads suppliers across regions, accepts slightly higher costs, and gains resilience across many futures. A family saves a modest amount each month, not to triumph in one lucky line, but to reduce strain across the largest share of plausible tomorrows. An athlete trains for contingencies, rehearsing adjustments for wind and fatigue, so that in most conditions performance holds steady. The mindset values median success with protected tails, rather than a glittering peak purchased by long shadows of risk. Language adapts to this posture. A manager stops speaking in absolutes. Instead of promising that a rollout will be flawless, the promise becomes transparency and rapid correction. A physician explains treatment in terms of ranges, side effects, likelihoods, and backup plans, and trust grows because reality is respected. A teacher frames exams as sampling moments rather than verdicts, then designs many routes to mastery so that one bad day does not decide a trajectory. Words shift from rigid forecasts toward commitments about process. The shift does not reduce ambition, it anchors it. Agency flourishes when it releases the burden of single-path heroics. A person can act boldly while recognizing that outcomes are spread. Courage, then, is not a bet on guarantee, it is a policy that favors benefit across measure. A writer sends a manuscript, knowing most branches lead to rejection, yet writes in a way that raises the odds of reaching the few branches where a reader feels seen. An engineer chooses a conservative design for a bridge, lowering the chance of catastrophe in heavy traffic. A neighbor learns names on the street, building networks that reduce harm when storms come. In each case, the act seeks to enlarge the region where well-being persists. Personal rituals translate metaphysics into habit. A morning checklist, a few minutes of quiet review, a list of 3 priorities. These small structures reduce the scatter of attention. The effect is not magic, it simply nudges many days toward coherence. Evening gratitude journals do something similar, shifting the sampling of memory toward patterns that nourish patience. These rituals become low-cost interventions that shift distributions in favor of steadiness, without assuming control over every variable. They are the ergonomics of choice in a world that permits many outcomes. Relationships acquire a similar ergonomics. Friendship is maintained not by dramatic gestures alone, but by a cadence of messages, shared meals, and small acts of reliability. Each act marginally increases the measure of futures where trust is still present when it is needed. In conflict, a policy of slow response and clear questions reduces the fraction of branches where anger ignites the room. In love, kindness is treated as a daily practice rather than a reserve for anniversaries. The ethic is simple: protect the ordinary, because most futures will be ordinary, and that is where a life spends nearly all of its time. Cities can be shaped with the same attention. Planners choose mixed land use so that neighborhoods remain lively after business hours, spreading safety across time as well as space. Parks are placed within walking distance of apartments, lowering barriers to well-being across many days. Transit networks are designed with redundancies so that one failure does not paralyze a district. Building codes favor simple, repairable systems. A city that plans for distributions stays graceful under stress, and grace becomes the background rhythm of its citizens. Finance, often an arena of brittle optimism, learns modesty. Portfolios diversify across uncorrelated assets, not to maximize headline returns in the best branch, but to sustain acceptable outcomes in most. Risk management stops hiding tails and begins pricing them. Insurance models refuse clever exclusions that collapse in rare events. Savings plans default to slow accumulation. Speculation remains a spice rather than a staple. The mood is not timid, it is disciplined. Education can be tuned for multiplicity. Rather than rewarding only the few who thrive under a single assessment style, the curriculum offers many demonstrations of mastery: writing, speaking, building, teaching others, designing experiments. Students learn the basics of probabilistic reasoning early, not as dry math, but as a language for thinking. Lessons include how to make decisions under uncertainty, how to update beliefs when evidence arrives, how to avoid being tricked by selective stories. Graduates leave with the habit of asking for intervals and error bars, and with a taste for plans that survive minor shocks. Health practices reflect the same wisdom. Sleep is treated as the foundation that shifts many days toward clarity. Nutrition focuses on patterns rather than fads. Movement is integrated into routines. Screenings are taken on schedule to catch small anomalies before they grow. Vaccinations are accepted as population strategies that protect the greatest portion of lives. The theme remains constant: build policies that move the bulk of futures toward wellness, then let exceptional lines be addressed with care rather than panic. Art does not shrink under this view, it brightens. A composer writes themes that can be varied by performers, sharing agency with the future. A filmmaker uses structures that reward multiple interpretations without collapsing into confusion. A painter embraces process that leaves room for accidental textures. Creativity becomes a dialogue with uncertainty, not a fight against it. Audiences learn to love works that hold up under re-watching because they contain distributions of meaning that land differently depending on the day. Spiritual life can live comfortably beside distributions without losing tenderness. Prayer or meditation becomes not a demand for one outcome, but a practice of attention and humility that stabilizes choices. Ritual comforts the mind when variance feels personal. Gratitude reframes the day so that common mercies are not invisible. Community provides redundancy in joy and grief, increasing the share of futures where someone arrives with soup when illness comes. The metaphysical details may vary, yet the posture is shared. Care for the many. Remain open to revision. Refuse despair. Technology demands particular caution. Systems that learn from data can unintentionally concentrate harm in thin slices of the population. Developers must test for tails, simulate extreme cases, and incorporate fail-safes that pause operation when patterns signal danger. Objectives must include fairness terms and robustness penalties. Deployment plans must accept rollback when unintended effects appear. The goal is to maximize the region where the tool helps while preventing small but crushing pockets of damage. Climate policy offers a textbook example. Choices today change the distribution of futures for centuries. The responsible stance is to reduce emissions quickly, invest in adaptation, and preserve carbon sinks, because these jointly decrease the measure of catastrophic lines while keeping room for flourishing. The arithmetic is plain. A small sacrifice now across many branches prevents heavy losses later across even more. This is not asceticism, it is attention to the geometry of consequence. Information hygiene becomes a civic duty. In an environment where narratives branch daily, a person learns to slow down before sharing, to check primary sources, to distinguish reporting from opinion, to avoid amplification of rumors. The practice reduces the share of futures where confusion distorts elections or harms strangers. Small habits, multiplied by millions, change the landscape. At the scale of a single day, the posture looks gentle. Choose policies that are kind to the common case. Repair quickly when surprises arrive. Keep reserves of time, money, and goodwill, and allow for beauty that is not planned. Accept that some lines will hurt despite care, and meet them without self-blame that supposes control was possible. Celebrate when a good result appears, not as proof of virtue, but as a welcome realization of a policy that often works. Hope thrives in this frame because it does not promise certainty. It promises influence. A person cannot bend every path, but can make it so that most paths within reach are softer underfoot. That promise is enough. It grants permission to act, to love, to build, to rest. It steadies the voice before a difficult conversation, because the aim is not to win a single outcome. It is to favor a region where understanding becomes likely. It calms the mind when plans must change, because flexibility is not failure. It is the form that wisdom takes when the world is abundant. At night, the same posture returns in quiet. Breathing slows. The mind reviews the day without verdict, notes which policies served, which need revision, and then releases the catalogue. Sleep begins. The body repairs small tears. Neurons replay their rehearsals. By morning, the lattice of possibilities still surrounds the day, but the person who will walk through it carries a practiced ease. Life remains finite, attention remains selective, and the silence between choices remains full. The task is not to master the many. The task is to be faithful to policies that make the many kinder. Night gathers like a tide that does not ask for permission. A quiet room holds a bed, a window, and the clockwork of breath that keeps time when all else sleeps. The ceiling carries a faint halo from a street lamp. Somewhere beyond the glass, leaves murmur against one another. A body turns towards softness, and the spinal cord loosens its careful guard. Muscles let go of their small wars. In that release, an invitation opens. It is not an argument. It is a simple gesture that says the world is large, the laws are patient, and the heart may rest inside that patience. The mind feels the edges blur, lists unspool, worries, trimmed by fatigue, lose their angularity. A picture rises for no reason and fades without protest. Just before the hinge between waking and sleep, a peculiar clarity visits. The room is known, the body is known, yet the sense of belonging extends past the walls, past the neighborhood, past even the planet that shelters this bed. It is as if a single thread is being laid gently across the chest, and that thread continues outward until it becomes a line drawn through an unopened book of possibilities. The book is not to be read tonight. It is enough to touch the cover. This is a civilization built on habit and surprise. Every morning, engines ignite, ovens warm, sidewalks fill with footsteps. Every evening, instruments fall silent, and kitchens dim. Between these rhythms runs the knowledge that matter hums with a deeper grammar. Wave functions evolve without abrupt erasures. Decoherence spreads secrets into the room and leaves firm outcomes in its wake. Horizons carry entropy like tally marks on their skins. Energies arrange themselves so that stars can cook the elements that shape breath and blood. None of these facts demand panic or worship. They invite attention. They suggest that abundance is not noise. It is the texture of a lawful world that can hold many stories without contradiction. Inside the dark, sleep is not surrender to chaos. It is cooperation with maintenance. Synapses adjust their weights. Memories consolidate, not like files being saved, but like paths being trodden until grass learns their shape. Emotions soften their edges and keep their lessons. The heart steadies its pace, then grants a little more oxygen to the brain as dreams build their cities. This maintenance has a posture that can be imitated while awake. Choose policies that favor steadiness. Protect the ordinary. Keep a small reserve of time and kindness. These are not grand theories. They are ways to remain in friendship with a world that will always be larger than understanding. The thought that reality might not be singular often startles at first touch. Yet, taken as an expression of consistency, it grows gentle. If the laws permit many outcomes and the mathematics refuses special exceptions, then plurality is a sign of honesty, not extravagance. This does not steal meaning from a single life. It multiplies the scenes where meaning can take root. Love does not thin because it may bloom on other branches. It thickens here because the mind that loves understands that care must be local and patient. Watch over this child, this friend, this street, water this plant, write this note. The vast does not demand grand gestures. It asks for fidelity in small ones. There is comfort in knowing that silence holds architecture. The silence in the room is not empty. It is full of soft turbulence from a billion tiny processes that never betray their craft. Electrons find stable shells. Photons travel and do not tire. Protons keep their loyalty to one another in the cores of stars and in the centers of cells. Gravity, delicate and relentless, binds hills to valleys and moons to planets. In this web of obedience, the possibility of many worlds is not an insult to significance. It is evidence that the rules are kind enough to allow variety without rupture. A person can sleep inside that kindness. The pillow is a modest technology. Cotton holds the shape of a head. Springs carry the weight without complaint. The air, warmed by the last breath, feels familiar. The eyes, freed from brightness, drift toward patterns the day did not have time to finish. This is the hour when forgiveness is most available. Forgive small failures and unfinished tasks. Forgive the voice that whispered fear too loudly. Forgive the day for being itself. In a world that might branch with every irreducible moment, there is still room to decide what tone to carry into the next. Choose a tone that makes many mornings gentler. The door to sleep opens wider. Words begin to lose their firm edges and become shapes. The mind, no longer anchored to the unyielding facts of furniture and responsibility, recomposes itself. The last clear thought before the drop is often simple. Thank you, or perhaps please. Gratitude and petition both draw from the same well. Each acknowledges that control is small and that care is large. Each returns agency to its proper scale. A single life is a precise instrument. It can tune policies, it can set tables, it can lift a crying child. It cannot command outcomes. That release is a mercy. Outside, the planet turns. Cities glitter on the night side like sprinkled salt. Oceans carry the moon in their hips. In the high air, particles born when the universe was a baby still fall in slender showers. In places where snow lies untouched, the cold arranges its crystals with a patient geometry that refuses repetition and yet always fits. On mountaintops, telescopes stare without blinking at a glow that remembers the first breaths of space. Not one of these scenes is diminished if counterparts exist beyond any horizon. The knowledge that more can be real does not dim the light that falls on this window. A lullaby for infinity is not a song about triumph. It is a reminder that the bed is an altar where time is trusted. The person who lies down is finite, and finitude is not an insult. It is the shape that attention must take to be tender. In the morning, plans will return and duties will call for exactness. Tonight, the work is to sleep so that the plans can be wise and the duties can be kind. Sleep is a vote for a future where patience grows. The breath slows again, the softest sounds grow vivid. A neighbor closes a door, a bus sighs at the curb and then glides away. The radiator ticks as metal relaxes. Somewhere, a distant dog raises a single bark and then decides against a second. In days to come, choices will be made, and those choices will tilt distributions toward health or harm. The person in this room cannot track all the ripples. The person can prepare to favor the swath where well-being spreads. That preparation begins here, in this ordinary room, with the permission to let go of control for a few hours and trust the machinery that never sleeps. It is time. The curtain hangs like a quiet wave. The window is a dark square where a single star finds a path between branches. Eyes close because eyes have earned their closing. The mind steps back a half pace. The body sinks a centimeter deeper. The world, so large, so steady, so full of lawful abundance, carries the sleeper as gently as it carries light. Let the night do its work. Let the heart learn the rhythm that keeps company with possibility. Let the last thought be a soft yes to a cosmos that prefers generosity to shortage. The room becomes a pocket of the sky that has learned to hold warmth. Sheets carry the memory of afternoons on a line. The pillow keeps the scent of rain. A slow tide pulls the body to a shore without footprints. The mind, lantern dimmed, floats with the care of a leaf on a lake that knows every inlet. Far away, comets lift their pale banners. Nearer still, a moth rests on the outside of the window and vibrates its minute engine like a prayer. Breath gathers the night and returns it made human. In that small alchemy, scale forgets its pride. Electrons pause their shimmer long enough for peace to cross the room. The heart keeps time. Sleep enters like a friend who never knocks. It sits at the edge of the bed and hums the first phrase of a song older than language. The tune does not promise safety, it promises company. It promises that even in a universe that admits many rooms, attention can inhabit this one fully and call it home. Clouds thicken beyond the roofline. A faint chill threads the floorboards. Somewhere, a train folds itself along a curve and is gone. Inside, warmth holds. In the morning, a cup will steam in the hand, and a window will silver with light. Work will resume. The world will ask for steadiness and offer beauty. For now, the answer is simple: rest. The future is not a single corridor, it is a field. Sleep to enter it wisely, sleep to carry tenderness into its paths, sleep to remember that abundance, when met with care, becomes grace.